Welcome to Agrifood Conversations, brought to you by iSelect, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is Luke Wazenchuk, an analyst on the iSelect team, and I'm excited to welcome you all to today's call. On today's Agrifood Conversations call, we are joined by Stefan Corgi, founder and CEO of Agrynex. Agrynex is developing enzyme-based crop protection products that deploy a naturally occurring antimicrobial enzyme system to protect seeds where and when it counts. They are currently applying their proprietary technology to seed disinfection solutions and seed treatment coatings in vegetable and specialty crop markets, and are targeting the large row crop seed treatment market. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in Agrynex market. You are potential customers for Agrynex products and services. You built and sold a company like Agrynex, or you are a sophisticated business person who understands Agrynex market and the challenges they may face. Before we begin, a few process comments. We are not soliciting investment. This presentation is to provide information about Agrynex products and services to help them find customers, mentors, and other strategic relationships that can help them grow their business. You are all on mute. You can use the chat window to ask a question. After the formal part of the presentation, we will answer as many questions as time allows. This presentation is being recorded and will be available for replay. And without further delay, I am pleased to introduce Stefan Corgi, founder and CEO of Agrynex.
Hi, everybody. So my name is Stefan Corgi, and I'm the CEO of Agrynex. Agrynex is a global agricultural innovation leader focusing on fungicide market using enzymes as a crop protection. The company was founded in 2015. It's a spin-off out of Cornell University, and our mother company is Amtronex. We have patented and validated technology. Currently, we're in active fundraising to grow the team towards formulation and registration of the product, and we are looking for strategic partnership and investors to scale and field test our solution. So we are playing in the broad market of crop protection because plant pathogens are a global threat to food production. First of all, crop loss to pathogens are in the tens of billions of dollars each year for row crops and vegetable crops. But more importantly, there's less and less solution available to treat these problems because of resistance occurring in the environment and a lot of product being retired in the marketplace. On top of that, the solutions that exist right now are using toxic chemicals, and this is something that customers are starting to realize, and there's more demand for safer solutions. Our core technology is what we call a Bionic Ant. We know how to stabilize and combine enzymes to make them work the best, and we have done that with enzymes that can control pathogens, bacteria, and fungi. It's a broad spectrum formulation that also controls nematodes and a trove of other pathogens that we can stabilize and assemble in a dry form that upon rehydratation activates and start producing free radicals that control the pathogens. The duration of the formulation can be controlled based on the quantity of enzyme that we're using, and at the end of the effect, all of the components of the formulation dissipates, leaving no residues in the environment. One of the key features of this technology is that it's synergistic with other active ingredients. So we can combine this broad mode of action with more targeted mode of actions, and we've demonstrated this with active organics and active conventional fungicides. We want to control pathogen when and where it matters. We think that point source solution are always better, so we're focusing primarily right now on the seeds. The idea is to provide higher quality seeds without pathogens on them, and also develop coatings that can control the pathogen when the seed germinates. we are also looking into applying our formulations towards foliar applications so that we can address the problem in all the stage of growth of the plants. But because we have some, because we showed some synergistic effect with different active ingredients from the conventional and non-conventional sector, we think we have our field of play is really broad. We can combine with natural ingredients, so we show that with essential oils, for example, but we also used conventional actives like serum as fungicides and others. So by co-formulating, we can play in the organic and commercial market. Another key feature is because we use this free radical solution, we show that there is resistance, management of the resistance that appear, and that's really key in deploying solutions that can be efficient for the long term. We also have, the solution is also very broad spectrum with the same type of formulation addressing fungal and bacterial pathogens, and that give us some key advantage against more single mode of action formulations. We are looking, first of all, for the global seed treatment market. This is our first go-to product. These are markets in need of new actives to treat a lot of fungicides, but also a lot of fungal and bacterial pathogens. And we're focusing on key territories, North America and Europe for now. Seed treatment is a growing market, growing at about 8% CAGR. And that is expected to reach about $10 billion in 2028. And our key market in that sector is about $2.3 billion for row crops and about $184 million for the treatment of vegetable seeds. More globally, because we're also looking at developing foliar solutions, we're also looking at the fungicide market more broadly, with an accessible market for us around $10.1 billion by 2028. The way we reach this market is to create value for the entire value chain by starting reducing the pathogens at the source, which start with seeds. So we're providing unique solution to seed providers to provide seeds with that pathogen, so better quality. And again, broad spectrum, so the same solution is being used for all type of seeds. Then we also provide protection of the seed when it's germinating. So it's basically added value for the chemical sector, but also for the farmers with key control protection. And down the road, because we can start reducing the quantity of chemicals used in the food for the production, then it's something that benefits to the safety of consumers. Our initial seed treatment products are based on our core technology that are patented, and we are developing the first product called Zampure, which is a seed disinfection product, some kind of bio-bleach that is used to sanitize seeds from pathogenic bacteria. So this is some example. We worked a lot on in vitro on bacterial spec pathogens, and we can control all of these pathogens. The other product we're developing is called ZamGuard. It's seed coating, and the seed coating is being developed right now to control damping of fungi, where not only can kill the pathogenic fungi, but also deter the fungi to attack the seed. So we've been developing our product in vitro. We're starting with also in vivo formulation, and we're showing that there's no adverse effect on the germination of the seeds. This provides us a distinctive advantage versus competitors. First of all, the broad spectrum, addressing numerous pathogens, fungi, bacteria, but also nematodes, versus other type of crop protection formulation that address only specific pathogens. We show that there is mitigation of resistance because we can co-formulate with organic ingredients, and because our enzymes are also organic or from natural sources. the product can be deemed natural, but if co-formulated with other conventional active, then it would be obviously a non-conventional product. We showed a drastic effect on pathogen loads, up to 8 log reduction, more efficient than existing solutions. And again, no adverse effect on germination, whereas other treatments to sanitize seeds often translate into decreased germination or vigor. The team is moving towards developing product and commercialization. I'm the inventor of the technology. The technology originates actually from Cornell University, one of the biggest land-grant university in the country. Helping us is Nick Macris, who is a specialist of natural product development, startups, and development of agribusiness. And the lead for the formulation development is Dr. Mary Donnelly, who is doing all of the bioengineering and testing of the formulation on the different crops. We also have numerous advisors to guide the product development, especially Dr. Alan Taylor, who is a specialist of seed coating and seed treatment at Cornell University. We also have plant pathologists from Cornell University, University of Florida, and University of Georgia that help us identifying the strains in circulation and which problem circulates in pretty much real time, so that we are aware of the pathogen that we need to try against. We are currently looking for a plant pathologist in California, but also in Europe on the market. We have business advisors like Wayne Mickelson, our legal counsel, and also one of our board members that knows the field really well, and Alice Lapp, who is a mentor at Cornell University. We are currently successfully transitioning from in vitro towards in vivo data. We bootstrapped this entire project with about $500,000 out of grant and a small investment. We first of all complete the in vitro work to optimize the enzyme, optimize the stability of the enzymes, doing co-formulation with conventional actives and organic actives. And we are already done a couple of rounds of in vivo testing with Zampure. We did that actually with clients in the US and in Europe. And a couple of rounds of optimization of ZamGuard, so with Cornell University, where we show protection against dumping off. So one of the key questions that we often have is when you're using enzyme is, can you source enough enzymes to be used for this crop protection application? So obviously, in early stage, some of the products that we use are pretty expensive because of the sourcing of the enzyme. But we know that the enzyme that we're using, extracting from milk, extracting from natural fermentation processes, and the cost can go down drastically. So for the field trial, for example, we estimate that the cost of trying for the application would be about trying seed coating or for application would be around $5 to $45 per acre. But with the optimization of the fermentation of the enzyme and the help of enzyme companies, they can produce large quantity of those. The cost of enzymes per acre could be reduced another 100 to 7-fold, bringing the cost to $0.05 per acre, which would put us actually in terms of a cost comparable to existing solutions. The key competitors for us are also potential partners because of the aspect of co-formulation. So we are starting to already work with seed companies, the seed companies that are helping us to develop the formulation, and we are looking for partners in the conventional and non-conventional sectors to co-formulate with them. So we are talking about fungicide, bactericide, but also small peptides and fermentation broth that are used to protect seeds. Our goal is to make formulations stronger and also to start reducing the concentration of other actives that might be detrimental to the environment, but also to the end consumers. The way we would like to distribute our product are twofold. First, Zampure, which is the seed wash. We intend to produce this to work with and sell to the seed companies. So that would be a sell direct. But for the other product, for the seed coating, and the foliar application, we would like to collaborate with strategic partners and distributors in order to sell the products. We are also open to licensing some of the solutions for geographic areas and type of seeds or crops. So in a nutshell, that was Agrynex. We are developing the solution that is radically effective for crop protection, and we are looking for strategic partners, investors, and clients that would like to help us developing these enzymes and new solution for the protection of crops. Thank you very much. And with that, I'll take any questions.
Thanks for walking us through that, Stefan. Really interesting stuff you guys are working on over at Agrynex. I had a couple questions. I guess we can start off with the efficacy approach date. So obviously, you guys are just beginning to shift into more in-field trials or specifically greenhouse trials. I guess I'm curious to know, with the limited testing that you've done, what is the duration of efficacy that you're seeing from a single application of your enzymes? How much longer do you expect to be in the greenhouse stage of testing? When are you planning on moving to outdoor? And what would you, I guess, expect to be your timeline to market if some of our viewers here are potentially interested in purchasing this product at some point down the road?
Okay. So in terms of the duration of the formulation, that we can control with the quantity of enzyme that we're using and I would say the substrate that we're adding. So we see a couple of weeks in vitro for protections. But we think with the co-formulation that give us a drastic extension of the formulation, just for the simple reason that we have different waves of sanitation. So our formulation with enzyme can act really fast as a first flush of sanitation, and the other actives can control. So this is why you don't need as much, and why you have synergistic effects. So that's how we think we can drastically enhance the length of the formulation. In terms of the testing, so we just started. So we completed some in vivo testing on a couple of crops. So we did vegetables. That's our first go-to market. So we did carrots, cabbage, tomatoes, and one of the key feature of the in vivo testing in greenhouses was to formulate the seed coating in order to make sure that the formulation lingers well and sticks to the seeds. So there was a lot of engineering there, and we think we have it figured out. So this is why it's working really well. So, and in terms now of product and go to market, we want to be very aggressive, especially for our first product, which is Zampure, the seed wash. So we think we can put the first product on the shelves and sell to customers within 2 years, just because it's a very focused point source treatment, but it's also a very important feature in the seed trade. A lot of vegetable seeds, for example, produced in the US, that are used in the US and not produced in the US. So making sure that the seed are clean, not carrying pathogen, is one of the key requirements for import-export. So with this, and because you have big companies controlling the seed market, we have a very consolidated base of customers there. So that would be our first product. For ZamGuard, for the seed coating, because of the field trial, that would add about 2 years. So we're thinking a go-to-market for that in 3 to 4 years. For the foliar, we would need to register, we would need to co-formulate and rethink the application. So it would be a longer endeavor. And this is why actually we are fundraising to start putting all of this in motion.
Awesome. Thanks for breaking that down for us. And then in terms of the products themselves that you're working on, you seem to have outlined a number of different, I guess, target indications that, this approach could potentially go after. You guys are you're developing fungicides, bactericides, and even some pest control applications as well. Do you see any one of those as being the primary focus long term? Do you see other applications that you could potentially expand into, 5 years down the road? Could you just give a little bit more of an explanation there?
Yeah, so because the formulation is broad spectrum, it's a free radical attack. It's actually also it's the first line of defense even for us actually. So we have similar enzymes on the skin, we have similar enzyme in the mouth. So we're just taking enzymes that are used by mammals and we're applying them actually to plants in another form. So this is why we can address a lot of pathogens. That said, I think the biggest market is the fungicide market. There is it's becoming more and more difficult to come up with new fungicides, and resistance is appearing really fast. Like we're talking always about antibiotic resistance, for the medical sector, but the same kind of things apply actually to the agricultural sector. And so the solution typically is to keep on increasing the quantity and the dose of the active. So in this case, we think that the fungicide market is the most important right now. In Europe, several fungicides have been retired from the market. The pain is real, and so that we think would be the biggest thing that Agrynex would do is provide new solutions in that market. In terms of the other type of applications, so yeah, we do control bacterial pathogens. We think it's very important for some key markets, vegetable markets, but also horticultural markets. So that's something that we're looking more as a niche market. And our idea there is to start pushing the product in this market and scaling up so that we can go after row crops. And row crops for us right now that are in our radar is corn, soybean, and wheat. Probably also looking at cotton really soon. So that's that's our key targets right now.
Awesome. And I think, part of your explanation, you highlighted a pretty relevant, I guess, broad concern in the fungicide market in terms of resistance being a concern across the board. Is that a concern for you specifically in the development of your fungicide product, or how does your approach, the enzyme-based approach, solve the resistance issue?
So the thing is, there's very little way for simple organism to withstand free radical attack. So it's not like an antibiotic that is very targeted, or fungicide that is targeting specific enzymes or protein. What our solution does is actually punching holes in membranes, and so it makes actually and it also interacts with the DNA, with all the machinery that is meant to protect the organisms. So plants and higher organisms like humans or animals have ways to handle that, but simple organisms cannot really do that. So this is why there's actually bleach is still efficient. There's no, for example, resistance to bleach. So this is the exact same thing, except that the free radicals that we produce are more potent and are produced actually with enzymes. So that's how this is the main difference. So the short answer is it's excessively difficult to resist free radical attack. And especially if we can combine our mode of action with other more specific mode of action, I think this is where we would make the most difference, in crop protection, where you can start to mitigate resistance appearance and give more efficiency immediately and also a higher life for the product that are being used.
Gotcha. Thank you. And then another question, is the USDA concerned with any potential downstream off-target effects that might affect the consumer or what's ultimately on the dinner plate?
So our formulation are meant actually to be used really early stage. So around the seeds, and we're developing all of our other solution so that the product does not linger. One key thing is enzymes in the US and in Europe are generally regarded as safe. So enzymes are protein. They would degrade at some point. We already have them in our food. We already have them in our detergent. They're really like part of everyday life products. So we don't anticipate actually, adverse effects in the food chain.
Gotcha. And are you anticipating that all of your products will be labeled as, organic friendly for farmers? Will farmers be able to profit on that boost in their ability to sell at a higher price point?
Yeah, that's a hope actually. There is very little product in the organic market that are efficient against a lot of different pathogens. So that's I think it's the key thing. And the enzyme that we're using can be extracted actually from natural sources. One of them is actually a component of milk. If you take a bowl of milk freshly from the farm, it would not spoil actually for several hours because these enzymes are in there and meant to prevent spoilage. So there is ways to get these enzymes from organic sources and to make sure that the entire chain is organic. So that's one of the hope.
Gotcha. And you also, in one of your slides, you mentioned that you have some recombinant enzyme research that you're doing in your pipeline as well. Will those also fall under the organic umbrella, or? Okay.
No. This one's because they're not coming from natural sources. We anticipate that they would not be labeled for organic, but we could the cost of those would be also lower. And we think that combined with other active ingredients, this is a solution for the conventional market to make conventional crop protection solution more efficient and more active.
Awesome, great. And then lastly, Stefan, what can the audience help you with? How can they find you if they want to get in contact? What's the best way?
So the best way is to contact us through the website. So my email is s.courget@agrynex.us. And please ask us any question if you would like to try some of the product. We are looking to grow the team. So if there is some people who are looking, for a brand new startup with a new solution, and would like to work for us, come talk to us. And obviously, we're a startup, so we are looking for investors to do our next step, which is growing the team, greenhouse testing, and commercialization of the product.
Awesome. Sounds good. And with that, we're concluding our Agrifood Conversations webinar. So thank you all for participating. We host these calls every Thursday at 3 p.m. Central. You can register for the Agrifood Conversations webinar series by going to agrifoodconversations.com. A replay of this webinar will be emailed to you in the next 24 hours. And if you know others that may want to see this webinar in replay, they will be able to access it on agrifoodconversations.com within the next 24 hours. Thank you for your time, everyone. Enjoy the rest of your week.
Thank you. Bye-bye.
Bye.